Hello everyone, in this video I'm going to be explaining the common ion effect. So our first question is, what is a common ion? So solutions containing both an acid or a base and salts must consider the ions that the two compounds might have in common. So suppose we have a solution with hydrofluoric acid and then the acidic salt sodium fluoride. Hydrofluoric acid is going to dissociate into H plus and F minus, where sodium fluoride is going to dissociate into Na plus and F minus. So the common ion here is the F minus, since it's produced by both the HF and the NaF. So because of Le Chatelier's principle, the acid dissociation of HF will be driven to the left by the presence of the fluoride ion in the solution from the salt. So the common ion effect makes the solution less acidic than the acid solution alone. Okay, so here's what a problem like this might look like. So we're going to calculate the pH of a solution containing 1 molar HF, and that gives me the Ka, and 1 molar NaF. So for my initial conditions, for my HF, I know that I have 1 molar here. I will have none of the original H plus, but for the F minus, I'm going to have 1 molar from the NaF. So here I also have 1 molar. Now the change here, it's going to shift towards the sides that has none of the H plus. It needs to produce some of that before it can start going the reverse direction. So I'm going to have minus X here, plus X, and plus X. Right. So at equilibrium, I've got 1 minus x, x, and 1 plus x. All right. So my Ka, right, is equal to the H plus times the F minus over HF. So I can go ahead and plug in and solve for x. So I've got 7.2 times 10 to the negative fourth. Right, that's equal to x times 1 plus x, and then 1 minus x on the bottom. So when I solve for this, I find that x is 7.19 times 10 to the negative fourth. Okay, that is going to be a concentration of H plus, right? 7.2 times 10 to the negative fourth. Right. Now, without a common ion, if I were to do this with the concentration of F minus originally as 0, so just finding the H plus for, the 1 molar of the acid, without the common ion, the H plus would have been 2.6 times 10 to the negative 2 molar. So you can see that the amount of H plus in solution is drastically decreased because of the presence of that common ion. So when I go to find the pH here, right, I take the negative log of my 7.2 times 10 to the negative fourth. My pH is 3.14, right? Compared to my original pH, which was 1.59. It has become less acidic because of that common ion. And that is the common ion effect.